a section where we're going to explore the graph of a function and really evaluate what we see on the graph, and then answer questions about the graph of a function. So if you look at your notes at the top, it says obtain information from or about the graph of a function. And example 1 says, answer the questions below for the functions shown. I'm going to pause this for just a second and sketch this graph real quick. Okay, so what you'll see, what you'll notice is there is like a dotted line, a vertical line that goes down through the point x equals 2. In fact, the graph of the function, the equation of that line, the function, is x equals 2. And then we have the curve that approaches that line. So that's the graph we're going to answer questions about. So first off, it says to find f of 5. Well, remember, when you use function notation, this means what x is equal to. So here it means x is equal to 5. So let's go to our graph and count over 1, 2, 3, 4, 5. And you will see that when x is 5, if we come down, and mine isn't exact again because I just sketched it, I don't have a grid on here, we see that f of x, or y, is equal to negative 4. So this point right here is the point 5, negative 4, and it is on our graph. And you can see how that relates to the function notation. Then it says to find f of 4. All right, well, we can do that. 1, 2, 3, 4. If we come down, it's actually almost at negative 3. So you could say f of 4 is approximately equal to negative 2 2/3 or negative 3. It just kind of depends. That graph is a pretty bold line, so it's a little bit hard to tell exactly what that is. I'm going to go ahead and we'll call it negative 3. So that means that the point 4, negative 3 is on our graph. Then it says to find f of 3. So let's do that. 1, 2, 3. That one's very easy to see. F of 3 is equal to 0, and so the point 3, 0 is also on our graph. So that's kind of the way we're analyzing a graph. We're just looking for those points and using function notation. Now let's go to the next set of questions, and it says, is f of negative 1 positive, negative, or undefined? So we want to look at f of negative 1. Remember, that means that x is negative 1. So let's go over to our coordinate plane and find x is negative 1. Well, I don't know about you, but I don't even see our graph going over there. So it's undefined. F of negative 1 is undefined because our graph doesn't even pass through that point. So it's not included in that function, in the graph of that function. What about f of 2? This is a little bit harder. F of 2 means x equals 2. Well, x equals 2 right there on that line. In fact, I told you that that is the equation of that vertical line. Well, notice our graph, as it's going up in this direction, it approaches that 2, but it never touches it. And that line, this line right here, that dotted line, is called a vertical asymptote. And what that means, kind of a funny word, but what that means is that the graph approaches that line but never touches it. So again, f of 2 is actually undefined because our graph doesn't go there. All right, but what about f of 2.5? All right, well, 2.5 is somewhere between 2 and 3, and if I travel up, you notice, oh yeah, my graph goes there for sure. And when it does, it's in the positive region. This region up here is all the positive region for y. So we would say that our graph there, the function is positive. F of 10, if I counted over 1, 2, 3, 4, 5, 6, 7, I only went to 7, so it would keep going this direction to the right. And obviously, if you travel down, you can see that's where that graph would be. So it's very much in negative territory, where y is negative, or f of x is negative. So that's what we're doing, is we are examining that graph to answer those questions, and you will be expected to do that. All right, let's look at example 2. It says, for what value of x is f of x greater than 0? Well, now let's think about what that means. F of x is the same as y. We want to know where y is greater than 0. That means y is positive, just like we looked at the last graph. So if I sketch this one, it's not going to be great, but at least you have your notes there where everything is nice. And it goes through the point 1, 2, 3, and it goes through 0, 4, and it goes down over here, 1, 2, 3, 4. It goes through that point, 1, 2, 3, 4. Mine isn't very even or symmetrical, but yours is, so you get the idea of how it's supposed to look. Okay, it looks something like that. All right, and we want to know where is the region where f of x is greater than 0. Well, starting right here and ending right here, all of this part of the graph, I'm going to kind of shade it, all of that part of the graph is in the region where f of x is greater than 0. Well, where does that go? It goes from the point x being negative 4, that's right there, negative 4, y is 0, to the point x being 4, y is 0. Now notice I didn't use brackets. It's not included there because actually at the point negative 4, y is not positive. It's equal to 0. So it goes right up to that point, but it doesn't include it. So that's why I use parentheses around my interval. This is an interval of what points we're talking about for x. The point negative 4x to x being 4, and that's where y is positive. The next part says, in the same graph, it says for what values of x is f of x less than 0, meaning y is negative. Well, going back, I'm going to use the same sketch and not resketch it, even though you have it again. And I'll try to draw it differently so you can see where I'm talking about. We can see that down here in this region that I am sort of shading with little curvy S's, that's where y is negative. Now notice it's not connected the way the last one was. This first region is all one connected region. So what I have to say is the region where y is negative, or f of x is less than 0, it begins down here somewhere at negative infinity. It goes up to negative 4, but doesn't include it, because remember, at negative 4, y is 0. So it's not negative, okay? And then that is in union with, now let's go over to the next part. It starts at 4, and it goes to infinity in the right-hand direction, because as this is going down, remember, it's going right. As this side is going down, it's also going left. That's where you get the negative infinity for x, and the negative 4 for x, and then the 4 for x, and the positive infinity for x. I think this is a little bit hard. It isn't really intuitive. All right, let's look at example 3. It says, for what values of x is f of x greater than 0? That means y is positive. And what we have again is our graph from example 1, and I am going to see if I can quickly sketch that for you. It'll probably not even be as good as it was the last time, given that that's all crooked. That's okay. We know that it looks something like this, okay? And we want to know, where is y positive? Well, y is positive right here, when it's above that x-axis. Well, what values, what interval values do we have there for x? Well, it's positive. Remember, it can't touch 2. So it's positive between x being 2 and x being 3, but it doesn't include either one. Let's think about why it doesn't. It doesn't include 2 because we have a vertical asymptote there. Remember, I explained that, meaning it can't touch that line. And it doesn't touch, it's not positive at 3 because at the point 3, y is 0. So it just goes in between 2 and 3, not including. All right, and finally, I'm going to use the same sketch. It says, for what values of x is f of x less than 0, meaning y is negative. Go back to our graph and we can see all of this region here and continuing on in that direction, y is negative. So what we would say is the negative stuff starts at 3, it doesn't include 3 again because of this, and it goes to positive infinity in the right-hand direction. Alright, let's look at example 4. And I'm going to take just a second, I'm going to pause it again, and I'm going to sketch this. Again, my sketch is nowhere near as good as what's on your drawing, but we can work with it. Okay, the question here says, if x equals 0, what is f of x? Now, this is a different question. We're actually saying that x is 0. Well, where is x 0? That means no traveling in the left or right direction. So x is 0 right here, because that point is the point 0, 6. So we would say f of 0, when x is 0, we have 6. All right, now that's different than this point and this point. X is not 0 there. Here x is negative 5, y is 0. Here x is positive 5, y is 0. That's not what we're asking. We're asking if x is 0, what is f of x? All right, on the next graph, again, I'm going to pause and sketch. All right, let's take a look at it. I didn't draw it very well. It says, for what values of x is f of x equal to 0? Or in other words, where is y 0? Well, y is 0 at any points that are still on that x-axis. So here y is 0, here y is 0, and here y is 0. So we would say f of 1, 2, 3, negative 4 is equal to 0. That's the first one. F of 0 is 0, and 1, 2, 3, 4, 5, f of 5 is also 0. So these are the 3 spots where f of x is equal to 0. Please make sure you understand the difference between this first graph where we're saying x is 0 and this second graph where we're saying f of x is equal to 0. It's a difference between a y-intercept and an x-intercept. That's all that is. Alright, let's look at example number 5. It says, consider the function f of x equals x plus 1 over x plus 2. And we're going to do some analysis of that graph. So, A, it says, is the point 1, 1/2 on the graph of f? What does that mean? If this is my x and this is my y, what that question is really asking us, it means, does f of, what is our x? 1 equal 1/2. That's what it's asking us. Does f of 1 equal 1/2? 1 and 1/2. So we have to find that out by going back to our function and determining what is f of 1. So let's do that. F of x is equal to x plus 1 over x plus 2. So f of 1 is equal to, take out the x, put in a 1, 1 plus 2, which is 2 over 3, which most certainly is not equal to 1/2. So the answer to that question, does f of 1 equal 1/2, is no. The point 1, 1/2 is not on the graph, because when we plugged it back into the function, we didn't get what we were supposed to get. F of 1 did not equal 1/2. All right, let's go to B. It says, if x equals 2, what is f of x? Well, that's a pretty easy thing to do, because we know that f of x is equal to x plus 1 over x plus 2. So right underneath it, I'm going to write f of 2, and I'm going to fill in the 2. 2 plus 1 over 2 plus 2. So f of 2 is equal to 3/4. And we found f of 2. That was easy. Then it says, so what point is on the graph of f? The point is x is 2, f of x is 3/4. So the point 2, 3/4 is on the graph. That's how those kind of go back and forth. All right, let's look at C. It says, if f of x is 2, not x, but f of x is 2, what is x? So what that's saying is the function f of x equals x plus 1 over x plus 2, we're saying that that's equal to 2. So what is x? All right, we need to solve this part for x, and we can do that by using the LCD to get rid of that denominator. So I'm going to rewrite it. X plus 1 over x plus 2 equals 2. That's what the question is asking us. What x makes y be equal to 2? So I have to get rid of the denominator by multiplying both sides by the LCD. That causes that denominator to cancel, and I have x plus 1 equals, let's go ahead and distribute, 2x plus 4. I can easily now solve that simple equation for x, subtracting a 4 from both sides, and I get x equals -3. So what does that mean? It means x is -3 and y is 2. And that is a point that is on the graph. So it gave me the 2, f of x, and that's where I put it right there. So I set the equation, the function equal to 2, and solved for x. It's not that these are hard, but it is a little bit confusing at first when you first start doing them to understand what they're really asking. All right, let's look at part D. It says, what are the x-intercepts of the graph of f, if any, and what points are on the graph of f? Okay, now we're still talking about this function. Let's rewrite it. F of x equals x plus 1 over x plus 2. And it's asking us for the x-intercepts. Well, now let's think about what an x-intercept looks like. An x-intercept has a number in the x spot, but a 0 in the y spot. That's an x-intercept. So it's really asking us, here's what it means, what the question means. It is when does the function f of x equal 0? When is the y 0? Well, in order to do that, we do what we did in part C. We set it equal to 0. So we say x plus 1 over x plus 2 equals 0. We solve it the same way by getting rid of that denominator always. That cross cancels. We have x plus 1 equals, distribute that 0 and you get 0. Subtract a 1 and you get x equals -1. Which means that point, -1, 0, is an x-intercept because f of -1 is equal to 0. So that is the x-intercept, and it obviously is a point on the graph. So we answered the question. All right, let's go to example 6. And again, I'm going to have to pause to sketch this before we do it. Okay, this one wins the prize for a crummy job of sketching, but whatever, you've got it on yours. So let's look at this question. Part A says, what are f of 0, f of 3 pi over 2, and f of 3 pi? Well, first off, we've got to take a look at our function and do some labeling on our graph, okay? So what came labeled for you is this point right here. It's the point pi -4. All right, so if I know that this point right here, this x is pi, then this one must be pi over 2. So this point right here, there's not really much room, is pi over 2, 0, which means this point right here, if this is a half pi, or pi over 2, a whole pi, this must be 1.5 pi, or 3 pi over 2, 0. Then we have 2 pi 4, which means this point, 2 pi is the same as 4 pi over 2. Think about it. 4 pi over 2 simplifies to 2 pi. Okay. This must be 5 pi over 2, 0. This must be the point 3 pi -4. Keep going. This is the point right here, 7 pi over 2, 0. And then finally we have the point up here, 4 pi 4. So now that we have it labeled, it'll be easier. So it says, what is f of 0? Well, where is x 0? X is 0 right here, 1, 2, 3, 4, and we have the point 0, 4. So f of 0 is equal to 4. All right? F of 3 pi over 2, let's find 3 pi over 2. That's right here. That is equal to 0. In other words, when x is 3 pi over 2, y is 0. And finally, f of 3 pi, let's go find our 3 pi, that's right here, and that is negative 4. So those points are on the graph. And I didn't really write these right because I started writing them as function format, and then I changed to point format. So let's scratch those off and let's write it this way. So f of 3 pi over 2 is 0. F of 3 pi is negative 4, but also you can write it as those points. Sorry, I didn't mean to be confusing. All right, let's look at B. It says, what is the domain? The domain, remember, is what x can be going left to right. So what's the smallest? Notice there's no arrows on this function. It actually stops. So what is the smallest x that we have? We have 0. Does it include 0? Yes, it does. So we have a bracket. What's the largest x that we have? The largest x is right there, and it is 4 pi. So that is our domain. Our range is how much ground that graph covers, going down to up. The smallest, the lowest that it goes is negative 4, and it does include negative 4. The highest that it goes, the biggest y that we have, is a 4, and it also is included. Let's keep going with part D. It says list the intercepts, meaning what's the x-intercept and the y-intercept. So let's first talk a second about the x-intercept. The x-intercept, remember, has a number here and a 0 for y. Well, we can look at our graph now that we labeled it, and we can find them all. So the first x-intercept, we have one right there. So we have the point pi over 2, 0. And we have another one here, 3 pi over 2, comma, 0. We have another one here, 5 pi over 2, 0. And finally, we have our last one right there, which is 7 pi over 2, 0. Those are our x-intercepts. Now let's talk a minute about the y-intercept, where the graph intersects the y-axis. Remember, it will have a number in the y spot, but a 0 for x. And there's only one place where that happens, and it's right there at the point 0, 4. So that is our y-intercept. E, it says, how often does the line y equals 2 intersect the graph? Well, before you can answer that question, you've got to be able to graph the line y equals 2. Y equals 2 is a horizontal line passing through the point y is 2. So it goes like this. Okay, that's the graph of y equals 2. And we want to know how many times does it intersect our graph? Well, 1, 2, 3, 4 times. All you have to do is count. It intersects our graph 4 times. All right? Let's look at f. For what value of x does f of x equal negative 4? In other words, where do we have negative 4 as our y? Well, right here and right here, there are 2 places. So we would say f of pi equals negative 4, because we've got this point, the point pi, negative 4, and we have f of 3 pi is equal to negative 4. Finally, and I hope I have room here, I've got G, and I redid your graph large so you could really see it. So you may want to go in there and label that. But it says, for what values of x is f of x greater than 0? Remember what that means is y is positive. Okay, well, let's look at the graph. Y is positive here, stop, and then again here, all the way over to here, stop, and then it's positive here. So I just have to be able to show that with the correct notation. So f of x is greater than 0 when x is in between 0, that means here, and pi over 2. So I'm going to write x is less than or equal to pi over 2, greater than or equal to 0. X is in between, okay, it's in between 0 and pi over 2. And then we union that with, here it starts again, all the way over to here, when x is in between 3 pi over 2 and 5 pi over 2. And then we union that with this little piece at the end where x is in between 7 pi over 2 and 4 pi. These questions aren't questions that have a lot of calculation involved. What they have is you being able to read and understand the graph.